What's up, guys? This is again your resident chemist slash teacher slash vlogger na din, joke, Mark. And today we will be discussing one subtopic subtopic in psychometry, which is the limiting reagent. Okay, so what is a limiting reagent? By its name, the limiting reagent, or also called the limiting reactant, is the one that limits the reaction. So it dictates how far the reaction will proceed. So how do they do it? They can dictate how far the reaction will proceed. It's because they are the ones that, among the products, the limiting reagent is the one that is consumed first, or rather, among the reactants, the limiting reagent or limiting reactant is the one that is consumed first in the reaction. So since it is the one that is consumed first in the reaction, the reaction will not proceed further without the limiting reactant kung naubos ang limiting reactant mo, because kulang na ang imong products or ang imong reactants para mag-react sila to form ang product as indicated in our reaction. So let's try putting this in context. So we have here a sample problem. A strip of zinc metal weighing 2 grams is placed in an aqueous solution containing 2.5 grams of silver nitrate, causing the following reactions to occur, which is stated here. So when we say aqueous, that means it is dissolved in water. So the question here is, what will be the limiting reagent? So before doing your psychometric calculations, the SOP gidna nga you balance the equation first. So if you can see the whiteboard there, so we have nope, not this one. We have zinc, which is in solid form, and the silver nitrate is dissolved in water. Sorry. Wala na siya dapat parenthesis. Sorry, guys. Wait. I move ko lang gamay. Medyo butok. So, here. Then, silver nitrate. Then you will produce solid silver, plus the zinc will react as zinc nitrate, and this will be dissolved in water. So aqueous. Okay. So let's try balancing this using by balancing by ions, since this is a single replacement reaction. So instead of balancing this reaction by elements, we balance them by ions para masapos. So our ions are zinc, silver, and nitrate. So here, this is the reactant side, this is the product side. So coefficients ng zinc, 1, 1, 1, silver nitrate. Same goes here. 1, 1, but nitrate, since it has a subscript of 2, we have coefficient 2. So among here, you find first which is not the most imbalanced. So dire, if you see here, among the ions, it's nitrate that is not balanced. So you balance by multiplying it with a certain coefficient. Since 1 na dire, 2 na dire, you multiply this by 2. Since your nitrate is attached to your silver, when you add a coefficient of 2 here, your silver will also be multiplied by that subscript. Okay, so is equals to 2, this is 2. So your nitrate is already balanced. However, your silver is not balanced. So you multiply 2 here on the product side of the silver so that mabalance siya. So balance, 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 balance na. And this is your balanced chemical equation. Okay? Then, after you do that, oops, I deleted it. I'm so sorry. Sorry guys, my video is not real time. delete ko siya. So, let's have another whiteboard. So, amo nang aton nga balance equation. Sorry, nabanas ko siya. So, then we proceed to our psychometric calculations. So how do we do our psychometric calculations? So we need to know how much of one product is needed to consume another amount of product, and vice versa. So in the context of our problem, we need to know how much silver nitrate is required to consume the 2 grams of zinc, and conversely, we need to know how much of the zinc is needed to consume the 2.5 grams of silver nitrate. So let's start first with zinc. So 2.0 grams of zinc. So by our psychometric calculations, we convert this first to mole using its molar mass, which is 65.39. Then we convert this to moles of silver nitrate using its coefficients in the chemical equation. I'm showing it again. Now, if you see in our chemical equation, in our balanced chemical equation or chemical reaction, the coefficient of zinc is 1 and the coefficient of silver nitrate is 2. So that means 1 mole of zinc is needed to react with 2 moles of silver nitrate. Or rather, if you have 1 mole of zinc, you need 2 moles of silver nitrate to consume that 1 mole of zinc completely. So we will use this as our conversion factor to convert moles of zinc that we have obtained in this expression here to moles of silver nitrate. So 2 moles, forgive my penmanship guys, I'm trying to make it fit to this whiteboard, equals to 1 mole of zinc, right? Then we already have the moles of silver nitrate and moles of zinc. We convert it to moles of, grams of silver nitrate using its molar mass. So the molar mass is 1.69 grams of silver nitrate to 1 mole of silver nitrate. And we cancel all the units so that the remaining unit will be the unit of what we're looking for. So this one, and the answer is, plugging this values to your calculator, the answer is 10.3918 grams of silver nitrate. Now we try this. Now we do this. We do the same process to silver nitrate. So from the 2.5 grams of silver nitrate, we get the amount of zinc produced. Okay. So we have 2.5 grams of silver nitrate. Again, we convert this to mole. So it's just the reverse of this one, okay? It's just the reverse of what we did previously. So 1 mole. So cancel, 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 cancel. So why are we doing this canceling of units? Because we need to make sure that the unit that is left after canceling out all the units is the unit of the one that we're trying to solve here. So when you cancel units, kung si gram silver nitrate out sa numerator, kag si gram silver nitrate ara man sa denominator here in our expression, i-cancel out mo na sila. So, cancel out mo na ang asa si grams zinc nga ginapangita ta ang magwa nga ang mabilin. Kay siya nang ginapangita ta. If the one that we're looking for, if the unit of the amount or value that we're trying to solve here gets cancelled out, that means your conversion or your psychometric calculations is wrong. And you have to repeat it, okay? So here, so 2.5 grams, that is equal to 0.4811 grams zinc. Now, comparing the two, and based on our given, comparing the two here, the two values that we have obtained here, and from our given, this amount is greater than the given 2.5 grams of silver nitrate. Okay, so that means you would need more than 2.5 grams of silver nitrate, which is indicated in our problem, to consume all of the 2 grams of zinc. Conversely, the 2.5 grams of silver nitrate will only consume 0.4811 grams of zinc, which is just a fraction of the 2 grams of zinc that is needed. So, based on that, based on our data that we have collected, that means this one will be consumed first. And this one, after all of this silver nitrate will be consumed, there will be some of the 2.0 grams zinc that will be left after the reaction. So that means your limiting reactant or limiting reagent is our silver nitrate. That will be our limiting reagent, okay? So next, we need to know how much of the silver is formed and on how much of the excess reagent that will be left. So for letter B, since we already know that the limiting reactant is silver nitrate, we will use the 2.5 grams of silver nitrate to calculate the amount of the silver formed, since it is the one that will be fully consumed in the reaction. So siya lang na ang makahatag kung pila man gid ang amounts of not only the silver but also of the other product, which is zinc nitrate, that will be formed. Okay, so silver nitrate. So we do repeat the same psychometric calculations, but this time our unknown here will be the silver. So 1 mole. I hope you can see. Yep, it's visible. That's it. 169.88 grams. Then we convert this to moles using our stoichiometric calculation, or using the coefficients in their balanced reaction, or you can just use the subscript of silver in silver nitrate. Since we can see here that the subscript of silver nitrate is 1, that means for 1 mole of silver nitrate, you also have 1 mole of silver. Okay, so let's try using this conversion factor. Nonetheless, it will still give you the same answer, even if you use their coefficients or the subscript of silver in the chemical formula of silver nitrate. Either way, they will both are correct. So 1 mole of silver is equals to 1 mole of silver nitrate. Then you have, you convert this to grams using its molar mass. So 107.87 grams silver over 1 mole silver. So again, cancel out the units such that the unit of the unknown is the one that is only left. If you can see here, only the gram silver nitrate is left. That means my conversions are correct. And your answer will be 1.587 grams silver. Okay. Now for letter C, wait, I'll transfer this. Now for letter C, we have shown that the limiting reactant is silver, silver nitrate rather. Now since we already know the limiting reactant, so the excess reactant or the excess reagent will obviously be zinc. So we have already obtained that in order to fully consume 2.5 grams of silver nitrate, we need around 0.4811 grams of zinc. Okay, so what we do is we subtract this value to the original 2.0 grams of zinc that was initially in the reaction. So the grams of zinc left is equal to 2.0 grams minus 0.4811 grams, which is equals to 1.5189 grams, or rounding it off to 4 significant figures, you will have 1.519 grams of zinc. Okay, that's it. It's simple as that. Okay, so I will be handing out. I'll try posting some videos regarding limiting reactants. Some videos regarding on how to answer some problems involving limiting reagents. I'll try to make some videos of those, but I cannot promise, okay? Because yeah, time constraints and such. Anyway, this is the end of my discussion about limiting reactants. If you have any questions, don't forget to email me. You know my email, guys. Don't forget to email me or DM me on Messenger, but I prefer email since it is more formal, and I usually get anxiety attack when someone DMs me through Messenger. Joke lang. Anyway, this is the end of my discussion. Don't forget to click the I button and subscribe. Okay? See